Alright, in the previous part of the video we had drawn our best fit line, figured out the slope of that line by picking a point on the line, not necessarily a data point, but a point on the line. And we determined the slope was 0.01. Now, we should put some labels on that. And the way to do that is look at the rise labels and the run labels. So this is newtons on the rise and grams on the run. So this is newtons per gram. And we're going to care a lot more about that later. But for now, let's bring that slope over here into our equation. 0.01. Now this x here is not a generic x, but rather it's specifically mass. Let's use m for mass. Okay, so there is our mathematical model. Let's rewrite that a little bit so it's a little bit simplified. 0.01 m. So what this tells us is the weight of any object on Earth will be equal to 0.01 times its mass. That is assuming weight is in newtons and mass is in grams. Alright, so there is our mathematical model. Now, let's go ahead and use that mathematical model. Alright, so what's the weight of a student who has a mass of 6,500 grams? By the way, that's not fairly typical for a larger high school student or so. Alright, so our mathematical model was weight equals 0.01 times the mass. Alright, so let's put our numbers in. 0.01 here, and now the mass, 65,000 grams. And so if you use your calculator, or some of you can do this in your head, you get 650 newtons. So a student who has a mass of 6,500 grams has a weight of 650 newtons. That's according to our mathematical model, our equation. Let's try that one more time. What is the mass of a frog that has a weight of 0.75 newtons? All right. Well, again, our mathematical model that tells us the relationship between weight and mass on Earth is right there. Mathematical model. Now let's put in our numbers. 0.75 newtons equals 0.01 times the mass. And in order to calculate the mass, I want to divide both sides by 0.01. That's just following the rules you've learned in math class. And that's going to be then 75 grams is going to be the mass of that frog. Now, what I want to next do is examine what is the meaning of this slope. That's one of our outcomes for this video, is what is the meaning of that slope. So let's go back to this page here where we first developed our mathematical model. And let's notice that the slope has as its label newtons per gram. What this tells us is how many newtons of weight every gram of the object has. So that's almost like a measure of the gravity on Earth, because gravity is related to the amount of weight. And so with more mass, you have more pull of the Earth. And so this is sort of a gravity constant for Earth. Other planets have different values for that. In fact, just if you're curious, Jupiter, which is our largest planet in the solar system, has a gravity constant of 0.025, or about 2.5 times as much as on Earth. Alright, so that's our first example of creating a mathematical model and using it and interpreting the meaning of the slope. In the next segment, we'll look at another example.